All right, howdy Texas. It's good to see so many party survivors after all. I left an hour early, so I was afraid that it's going to be an empty room, but you party hard and you wake up early, that's good. So it is a great honor to stand here, especially given that, as Mason said, I was here last year and nobody had an idea who I am. So it is a special honor to be here and keynoting. So I'm Hynek. I'm a software engineer at a boutique German web hosting company called Wahre Media. It's boutique because I've been forbidden to call us small. I'm also an open source maintainer, always on the brink of burnout, and a future famous YouTuber if I actually got my act together and produced more videos. But yes, this one was 40 minutes long, so that should take you a little bit. And while I hate SpawnCon, just as the next version, I have to acknowledge that I wouldn't be standing here if it weren't for Tidelift and my amazing GitHub sponsors who provide me with the necessary side income to be able to casually fly over to Texas, 23 hours door to door, by the way, and share my humble ramblings with you. And my ramblings today are about software design and about pressures and on your precious applications that affect your design in ways that you might not like without you being aware it's happening in the first place. But first, let's make sure everyone is awake, and I hope everyone took their blood pressure pills. The use of I had 3 shots in my coffee, so let me try again. The use of relational mappers and class-based validation frameworks ruins your project. I put some plants that are supposed to gasp, but I didn't hear the gasp. So I hope everyone is awake now. And in YouTube land, we call this an attention hook to stop people from closing the video as a sacrifice to the retention graph gods. And depending on whether you deliver on it or not, determines whether you're a great filmmaker or a scammy baiter. So let's see if I can pay down this bait debt. And let's start by adding a little bit of nuance. Like Django and SQL Alchemy and Pydantic and Marshmallow are just fine. But they're fine only as long as you're aware of what effect they have on your code. And this is today's topic. But the concept of design pressure is not specific to any of this. It is a foundational concept, and I will have examples that have nothing to do with either of those. So don't worry if this is not your jam. Because this is a talk about architecture, and this is not a talk about tools. And therefore, I am not here to take them away from you. My emphasis is not on ORMs or validation frameworks, it's on the unreflected. And my goal for today is to make you aware of the trade-off that you're making, and it's trade-off that you're most likely doing subconsciously. And as good old Carl Gustav already knew, this is not great for you. Design decisions need to be deliberate and not a matter of perceived fate. And as such, I'm not here to lead your thoughts. I'm here to encourage you to have thoughts in the first place. But to get there, we have to clarify one thing first, and that is, why do we even write software other than for money? Money is great. Is it to access a database? Unless you're writing a database driver, probably not. Or is it to validate some data coming through a web API? Also unlikely, unless you're doing some web filtering. You probably write software to achieve a goal using whatever tools you're using. And the core logic that does that is often called the business logic. And as with everything in software engineering, there is a passionate debate about what it exactly is. But this is my talk, my library, which is, I've always wanted to say, this is my rules. And for me, it is the code that decides what to do based on data coming in from databases, some kind of user input, like a web API or a file or CLI arguments, and most importantly, third, business rules. And the term business logic harks a bit back to the times when computers wouldn't fit into this room and only stood in banks. But your business might also be curing cancer, which would be great. So business logic doesn't have to be about shareholder value in the first sense, although it usually is in the end, but it is about the core value that you're delivering. And sadly, in many cases, business logic is just a bunch of if statements that are buried somewhere in a web view or a CLI endpoint. And they are just mixed up somewhere between form validation and database access. And this is especially true for tutorials, that make you implement simple block engines or to-do apps, because they're teaching you a framework and don't want to distract from that with complex out of framework logic, which makes sense. But thanks to that, many beginners haven't ever seen explicit business logic in their whole life. They may not even be aware that this concept even exists, that there's something they should think about. But this is the code why an application ultimately exists. And the way it's squeezed in this example might give you a little bit of an idea of what I'm going to talk about today. And I acknowledge that it feels a bit quaint in this time in human history to talk about design pressure when the biggest pressure many software engineers are facing right now is looking at a gargantuan pull request from Claude or Codex and fighting the urge to say it's fine. Or even worse, not looking at all, and just going, it's probably fine. Everybody does it. I read it on LinkedIn. And then just inventing some fancy new term to not have to call that gross negligence. Who knows how this talk will age? Like, I cannot predict the future either, but at the current state of the art and the current trajectory, software design is going to be more important than ever, not less. Especially if you specifically have decided to never write a line of code again. Because congratulations, you have become a full-time reviewer of an endless spring of new code of widely varying quality. And the fact that most developers aren't trained for that can be observed absolutely everywhere as we watch software getting even jankier than it already was. Oof, a single line, and it's not even a good one. By the way, I acknowledge that they are also getting hammered by AI right now because a lot more traffic, but also everything got more janky inside. Like, it is not good what's happening to GitHub right now. And I'm sure you also saw this one. So, there is a reckoning on its way. So as the savior of Python packaging just wrote, you are the only line of defense against a tangled mess. And reviewing code requires understanding code. And not just the new code, but you also have to understand the old code to be able to predict what impact the new code has. So unless you want your clanker to poorly rewrite the whole app whenever it needs to fix a bug or add a new feature, because it takes more than AGI to understand some highly tangled mess, you better hone your skills. And you better develop a strong taste in software design so you keep your bots in line. And with that, let's talk about design pressure. And I would define it as forces that shape your code unintentionally. And I've encountered this term for the first time in J.B. Rainsberger's seminal talk, Integrated Tests Are a Scam. So yeah, they did Beatty titles even 10 years ago. It's not a new thing. And he talks about how growing the scope of a system under test, so for example, you're testing a class, instead of testing a class or function, you're testing the whole thing, like the whole package or the whole service layer or end-to-end. If you grow the scope, you limit the design feedback from your tests about your code. In other words, it's masking the pain of a bad design. In other words, you get away with tangled, highly coupled code because you don't feel the pressure in the form of pain, the pain of testing coupled code. And this is another issue that got worse with stochastic code generation. Because if you tell an LLM bot to write tests for a pile of mud, it will spin up a Kubernetes cluster if it has to behind your back. It literally cannot feel the pain of growing the scope. So it only feels burnt tokens, which you will feel by running out of them or by the bill at the end of the month. So your job, again, is to provide the guardrails to not end up with a test suite that tests absolutely nothing because everything is monkey-patched mocks, or that tests everything, including AWS, and takes 1 hour for an Hello World web view. So what exactly is coupling? So 2 pieces of code, for example, classes or packages, are coupled if they can only be used and understood by looking at both. Changing one usually forces you to change the other 2. So coupling makes it harder to test, change, and understand your code because you have to look at 2 things at once. And that's a pretty important property in the long haul. But on the other hand, you cannot have no coupling if you want to do anything useful at all, because otherwise you just have a bunch of disjunct objects. So what you have to do is to actively manage coupling. Because coupling is one of the prime sources of complexity, and managing can be as simple as making your relationships unidirectional. So only one class knows about the other, but the other does not, right? It's simple things like that that will that help you a lot with making these connections tractable. But you certainly don't want to have to understand the intricacies of an ORM or Cthulhu forbid, a web framework, when trying to understand the logic that decides on the amount of radiation you're going to blast at a human being, right? I mean, Therac 25, anyone? I mean, it's a European thing, but it's still pretty famous. It should be famous under software engineers. It was like a race condition that caused people received 100x of the radiation they were supposed to get, which did not end well for those people. And since you're writing tests the whole time, I swear I had that before Al. I'm very angry at Al, wherever you are. I was so proud of that. So, since you're writing tests the whole time, you get the feedback that your code is too coupled from the get-go, because writing tests for coupled code sucks. So, you don't have to wait for design feedback until you need to add a feature a year later, or when hectically trying to debug it because something terrible happened and you might go to jail. Just kidding, crime is legal now, who cares? So, this point has been made many times before. Testable code is better code, because it forces decoupling on you. And obviously, absolute statements like this are complete nonsense. You totally can design a system so decoupled that you don't know which parts work with that, with what, if things are still coupled but you cannot see it. That's a bit of a common thing that juniors do when they are trying to decouple things. And there is the concept of test damage, which is complexity in your production code that only exists to facilitate testability, and clearly too much of that hurts too. But overall, in my experience, testing is a force of good, and I've seen a lot more coupled masses than significant test damage in my life. So this is our first design pressure of the day, and it is the good one. Having to write tests without monkey patching and mocking half of the universe leads to less coupled code by being painful if you don't manage it, which makes the code easier to change and understand, which is, generally speaking, good. In fact, I've heard the argument that the main function of writing tests is specifically the design pressure for better software design. And the tests are just this nice side effect that you don't throw away now that you have it. And I wouldn't go as far as myself, because returning to a project after a year that has 100% test coverage feels very different than coming back to one that does not. But I got a point. And this part should therefore be relatable to everyone, because it doesn't matter what kind of code you write, we all run into testability pains, like one of the most common things people like to ask about, how do I write good tests? And the answer is usually that you have to structure your actual code for it to be testable. It's not some magical package that makes testing easier. But acknowledging that pain and letting it guide you instead of claiming that you're like the one snowflake whose code cannot be tested will improve almost everyone's life. So, next, let's look at a design pressure that's neither good nor bad per se, and I use a great talk I saw at PyTexas 2024 to illustrate it. It's called The Rising Sea. And in it, Matt Drury shows a very elegant solution to a problem from advent of code, our beloved tradition of vowing to use it to learn a new language, usually Rust or something really obscure, and giving up on day 6 because surprisingly this year too life is too stressful and it's just too much work. But once the next December rolls around, we have learned absolutely nothing. And he frames it as a conflict between two mathematicians, and I recommend watching the whole thing because it's both entertaining and enlightening. And I will not spoil the entertaining part, just the boring takeaway. So the input to your program is a harbor with stacks of boxes. And the letters in the square brackets are boxes stacked on each other, and each stack has a number from 1 to 9. And then you have instructions telling you what to do with those boxes. Like move 5 boxes from stack 4 to stack 9. And then channeling one of the mathematicians, I'm not going to tell you which one, he gives himself a design maxim. You should structure your data so that the problem solves itself. You should structure your data so that the problem solves itself. And then he goes off and does just that and models the problem using nice, clean classes. An instruction class that encapsulates a move. A harbor class that consists of stacks and executes instructions. And finally, a stack that consists of boxes and allows to add and remove boxes to and from the top. And the boxes themselves don't matter here at all. It's just containers. It can be strings, whatever. But these classes combine the business logic of harbor box management with the data structures to work on. And this makes it a domain model. In software engineering, a domain model is a conceptual model of the domain that incorporates both behavior and data. And a conceptual model in Python is just a fancy word for a bunch of classes and how they relate to each other. And a domain model tries to reflect the domain in which you are solving your business problems, in this case, a harbor. So you could say that a domain model is domain knowledge distilled into code. And that is ultimately what we do when we create software. Whether we know it or not, this is what we do. If we do doing anything worthwhile solving. And meanwhile, a data model is something completely different. It's for all intents and purposes the database schema, and it's very annoying that it sounds almost the same. Because one of the biggest sins of software engineering is the constant reuse of terms. It feels like all important concepts have to be named using a permutation of the terms model, event, domain, and service. And don't get me started about working at a web host that registers domains and runs services. It's great. Oh, my domain service domain. Anyways, so this is the precious. The domain model, no matter how small, and it tends to be on the small side compared to the rest of the application, is the reason your application exists. The rest can be as shiny as it wants, but if you screw this up, your application is cooked. And coming up with a domain model is called domain modeling, and obviously the chances of not screwing it up are way higher if you think about it as a separate step, if you focus on this step. And the quality of a domain model is a function of how well it reflects the domain and how understandable it is, which I think Matt's code delivers on it really well. It even fulfills the Platonic ideal of a domain model by being completely isolated from everything that is not part of the domain. So there's no framework, no I/O, just behavior and data. On one look, you can identify the entities and their relationships and understand the business logic they implement. It doesn't even need conditionals like if statements, which is always a very good sign. But this kind of raises the question, why don't we all write software like this all the time? Why does this look like academic software from a programming book? Well, Matt was not done yet. And as a plot twist, he shows us one more code slide, which he calls the darkness. Ew, right? So this code is necessary for the elegant code from before to do its work, because it parses the input that you get from advent of code and manages it into nice and clean harbor objects. And please don't try to read it. I've counted 6 for loops alone, and I might have missed one. So this code has nothing to do with a problem domain at all. And the actual crane-moving code only gets to be elegant because it knows nothing of this filth. So this is the buffer between the data coming in and the business logic. The incoming format can change. It doesn't matter for the business code. The business code can stay the same as long as the business stays the same. So Matt concludes that the shitty stuff, his words, not mine, should happen on the outside layer of your program that interacts with the outside world. Once it's inside, organize it into nice data structures so that operations, i.e. code, are as self-evident as possible. This is the key lesson. It's another way to say validate at the edges, but he goes a step further and says to reshape your data at the edges too, such that it serves your problem. This buffer between layers, it doesn't have to be a parser that you wrote yourself, like in this example. It can be someone else's parser, like PyTexas. It can be an ORM, it doesn't matter. But it's important that you transform it into beautiful harbor objects. And what this is all about is that you are taking agency here over the shape of the data before you work on it. You do not let others force the shape of the data on you. Because what we've seen is that the shape of the data determines the shape of the code. Like this example was excellent for that. And that is design pressure right there. If he'd mixed parsing with executing, which would have 100% happened if he just started coding away on the problem, his code would be much worse. And the business code would be much harder to understand, let alone find. But it's our first instinct, just coding away and letting the shape of the input dictate our algorithms. And it's the answer why we all don't write software like this all the time. But Matt removed that pressure completely by converting the input into something that is well suited to his problem first. So the shape of the input that you have no power over has no influence on the shape of the business code. So, as promised, still no ORMs or validation packages inside. This is foundational and relevant for every single one of you, no matter what code you're writing. But with this in mind, let's talk about ORMs and class-based validators. And they both tend to call their classes models, which fair enough. As I've said before, there's only like 5 terms you're allowed to use to name things in software engineering. But those models have wildly different design goals, conflicting goals, which makes it so confusing, especially for beginners, when they see models everywhere and it's something different in every single project. For web APIs, the shape of validated data is dictated by the shape of your API, which in an ideal world, and if you're not an asshole, is shaped by what is ideal for your users to use to achieve their goals. But what people want to post is almost never what I want to work with. And this is why some call it an external model. The shape of ORM models is dictated by the shape of the data model, aka database schema, aka table design, with various levels of adjustment power depending on the ORM. I mean, especially SQL Alchemy has a lot to offer to munch table shapes in something more convenient. Django has a pony, and let's leave it at that. I love my Django friends. So a database schema has very different design considerations than an API schema or a domain model. For SQL databases, there's always a tension between performance, normalization, and redundancy. We've all had this in college if you did like Database 101, the 4th normal form or whatever it's called. In old school companies, they are often even designed and maintained by dedicated, usually grumpy DBA teams that don't care about your business code at all. They care about indexes and that's tuples. And I've been to an open space at PyCon US once, and there was one of those old school people, and there was this tension between people who want to write applications and who run the databases. It was kind of intense to be there. Justin was there. They got really angry about, at some point one of them said something like, this makes our databases just a tool for you to achieve goals. And we're like, yes, that's a database to us. Right? Okay, I don't want to go on too big of a tangent. I don't have that much time. I have a lot of slides, but still. Yeah, so I'm not going to do a Q&A afterwards because it never works for me, but I will do this walk and talk thing probably. So if you want to talk about me about anything that I've said here, come with us too. So where we are, dead tuples, yes, dead tuples. So obviously this is a very internal model, and maybe phrasing it like that already starts lighting up some light bulbs that maybe the internal external model should not really match-ish. So finally, your ideal domain model is dictated by the shape of the problem that you are solving, and that's it, nothing else. This is obviously an internal model too. Your users don't care how you solve their problems, as long as you do solve them correctly, which is a very high bar nowadays, sadly. And since it's the most important code in a project, you usually, or ideally, want to get all the help that you can get from your language and ecosystem that they have to offer, that you get it right. So like making illegal state unrepresentable or static typing is great. And it's a design pressure on its own, as Lukas taught us 4 years ago. Oh my God, it's so long ago. And that gets really difficult with, for example, Django's ORM. The moment you don't want to overfetch data and use models object values that takes strings to choose the columns to fetch. You can't hope to make that type safe. And if you don't think overfetching is a problem, a Django JSON friend of mine told me that someone at this company found out the hard way that there's a limit of 1,664 columns in a Postgres query. So this is what you get from careless joins, probably recursive. You couldn't go into more detail, but that's what I imagine happened. So if you don't limit the columns you need, this will happen to you. And it's always bad to just fetch everything, because it's a lot of load, a lot of data going over the wire. And just because an ORM hides database details from you doesn't mean that those details and limitations don't exist anymore. I mean, it adds its own foot guns on its own, as we've learned yesterday in a lightning talk. You get a whole swath of new ways to shoot your likes away. So my business code also needs different kinds of information depending on the state that an entity is in. So, for example, when I'm dealing with invoices, I'm interested in different kinds of data depending on whether they are open, paid, or overdue. So when dealing with open ones, I want to know when they're due. When dealing with paid ones, I probably care about when they've been paid. And finally, when dealing with overdue ones, I start caring about how long they've been overdue and how much reminding has been done to them. And one reason why people get so itchy is because these classes are so similar, right? But as Sandy Metz so wisely said, a little bit of duplication is far better than a wrong abstraction. And trying to shoehorn things together usually ends up in some kind of impedance mismatch. And especially when dealing with overdue invoices, and deciding whether you start debt collection on real people, the focus shifts completely. You're still looking at the same data coming from the same source, but you're interested in a different perspective on the same data. And you probably need to enrich the invoice data from other sources too, so you need to compose your ORM models, or even call a third-party API, like a debt collection agency, to see what's happening there. So the question is not what attributes an entity could have, what kind of data is in the database, but what you want to do with it, and what data do you need for it. Since this code can have devastating consequences, I want my business logic to be as straightforward as possible, and my data structures as clear as possible. I certainly don't want one generic big blob of optional fields here. And having classes with a lot of or none type annotations is one of the biggest design smells there is. And again, some tools offer ways to make this problem less severe, like tagged unions, table inheritance, or field aliases. But they're underused, strictly advanced features, and they usually still fail on the last mile when things get more complicated, which is usually where it'd be most important, right? So how do people usually deal with this conflict? So the most common bad approach is that you pick the web API or the database schema, but never the domain model, because you maybe even don't even know that's a thing, right? And you use it as your primary model, and you let the rest conform come hell or high water. And when starting with the database, there's even a name for that, database-driven design, which is, please don't write that down, this is a pejorative, this is not a best practice pattern. All right? There's square quotes. So either way, it means that you're starting on your back foot when implementing business logic on what essentially is raw data, and or a web API that allows me to guess your database schema, and or a database schema that would make anyone with a background in database design take up goat farming. So, but the bad news is that this is just a middle bad case. There's a worse one. Yeah. The worst case is that you balance the needs of the web API schema with the needs of the database schema. Maybe because you want to use the same models in both, because you thought that's a good idea. And you're getting mediocre results already. But then, you force the resulting foul compromise on your domain model. Meaning it's impeded not by one impedance mismatch, but two. And this right there is the reason why I find the combination of ORMs and class-based validation packages so unholy. Because the domain model that is foundational to the quality of your business logic is squeezed between two layers with conflicting goals. And to be clear, that all three have conflicting goals, right? And these packages just lure you in with the convenience of promising you the dream of a unified data model across all layers, which looks great on slides, but this is the result of the dream, and I find it more of a nightmare. Because if the shape of the data shapes code, then weirdly shaped data shapes your code in weird ways, right? And it can't be anything but weird, given it's dictated by a compromise between the database and the web API schemas. But again, this is not the fault of those tools. These tools can be used correctly, and you can make the same mistake without those tools. It's a systemic problem of trying to force a unified model on layers with conflicting goals. But wait, it gets worse. In theory, with API versioning, you can change web API details anytime. In theory, with database migrations, we can change the database schema anytime. Quick show of hands, who has changed web API details in a fundamental way? Moshe, you don't count. Right. So, on the hands up, who does not get a bad feeling in their stomach when they're doing database migrations? Yeah, no. Because in practice, they calcify the shape of the already imperfect data, because changing web APIs angers your users, even if you have versioning. But it's like with Semver. You can bump your major as much as you want, people are still going to complain. And you're more likely, in my experience, to have to re-implement an existing shitty API with a horrifying schema, but with new technology, because your users are depending on it, and they don't care about you wanting to do things in a clean way. And database migrations, that's why I'm asking, are still tedious and problematic, especially under load. There is no really good way to do that under load without a downtime. I mean, there are ways, but they're always very tedious. And what I'm hearing is also like circumstances tend to lead to a loss of control over your database tables eventually, if you ever had a control in the first place and not some grumpy DBAs. And this means that you almost never get to design those models, and changing them is almost always too painful. And if you take that to its logical conclusion, and if you let this happen, it means that you have lost control over your domain model. And since the shape of the data shapes the code, you've also lost control over business logic, and this is bad. And while this topic was marinating in my head, one Adam Montgomery wrote a blog post entitled How I Build, which refreshingly, despite coming out only last year, which feels like a million years ago, was not just AI bootlicking. And it had this killer passage that matched my experience, and I found very liberating at that moment. It's okay to have duplicative-looking types for different layers of a project. For example, ORM, API schema, and business logic. Types need to be easy to change and reason about, so we can adapt them to our evolving requirements. And this, adapting to evolving requirements and evolving understanding of the domain, in my experience, separates the mid from the great. And he goes on. Types near the edge, like API schemas and database tables, are inherently less flexible. Users, grumpy DBAs. It's often better to explicitly map types between these layers rather than create a Franken type and allow the least flexible layer to calcify the rest. And wow, this is my talk in one slide. It was almost spooky to stumble over it while I was thinking about all of this. And to map types here means convert to a better type. So what he's saying here, that should be okay, you should be okay with having 3 classes for the same thing, depending on what you're doing with it. And I'm going to add, it's okay to have more than 3. Now, who wants to see another example? Right, everybody. So I will try to show you something, but as Kent Beck once wrote, good examples are by far the hardest part of explaining design, because we usually can't just take something from prod, because A, copyright, unless you're a billionaire, and B, they usually only make sense in the context of a larger system, which adds a lot of noise. But let me try anyways and use something very banal, and it's international postal addresses. Exciting, right? Yes. Given that there's countries where a postal code is enough to receive mail, like Ireland, that in 2015, after being one of the last countries in the world to not have postcodes, decided to go all in, and now a postcode is enough to receive mail. And combine this with that there's still countries that don't have postcodes, and I'm sure there's people in Ireland who refuse to use postal codes out of principle too. Practically speaking, every field of an address is optional. Now, remember what I said about classes with many or nones? So this is not a domain model, this is a data model. You add an ID and you've got yourself a perfectly cromulent database table. But this is not useful when trying to write any kind of business logic around this, or trying to validate an incoming address. It tells me nothing about the concept of a postal address. I could use a dictionary instead of a class here and lose nothing, except that it's a little easier to type. And just imagine trying to add any kind of behavior to this class. You either end up in a quagmire of if, is, none statement, or you end up doing some kind of dispatch on a country field, and you still have to fight the type checker at every step. And assuming you're writing code where the shape of the data matters, for example, formatting addresses for printing on envelopes, you can hide a different valid shape somewhere in the code in a Rube Goldberg machine of if, none, and match statements, or you can make the shape explicit and define them like here for the US of A. Looking at a US address, you know exactly what fields exist. A function that takes a US address as an argument knows exactly what it's getting. It's defined in code, and it's validated by MyPy or TY. You can quite easily feed something like this into Pydantic too. So when using this class, you know that you can use all fields without checking first, except attr2. And of course, this is not Java. You can totally also pass 6 arguments to a function. Nobody's going to stop you. Arguments that have the correct type annotations. So You will have to fight a type checker when invoking this function, because clearly you know it's str if its country is the USA. But once you're inside the function, which is in this case the most important code, the type checker is your ally again. It is the aforementioned buffer between some kind of input and your business code, right? It's a one function call with one type ignore. Now, what am I actually suggesting if it's not to ditch all your tools? In an ideal virtuous case, I want you to start with a domain model. Ask yourself, what's the problem you're solving? How can you implement it best? What data shape is the best for that? Then I want you to understand how your users would want to interact with your system and give them the best possible experience, whether it's a GUI or API or CLI or some other three-letter acronym. And given that your business logic is not coupled to the interface, you can give them more than one, right? That's no problem. So not letting your early understanding of the problem dictate your business code allows you to provide a better user experience for more people. And also, like in my experience, every serious web application at some point has a worker queue. So you have to, which runs the business code. So you will end up eventually with multiple entry points anyway. And finally, third, I want you to understand the optimal shape to store and retrieve your data, whatever that is. And I want you to be aware of the conflicting goals of all three layers and adapt the data to its optimal shape for each case, understanding there might be more than three. So in the case of database access, this could be applying a repository pattern that uses the convenience of an ORM to build database queries, but spits out neat and clean data classes with encoded state and nice types, and with as few optional fields as possible, which also decouples the state, the data from the ORM, and therefore from any kind of accidental I/O or accidental transaction begins because you accessed an attribute, which makes them much easier to test, which brings us to the first design pressure. And in the case of the web API, it can mean that you use Pydantics tagged unions to receive a narrowed down class with very tight typing constraints. But of course, as you might have noticed, we do not, in fact, live in an ideal world. And this is software engineering, which means it depends. And we are talking trade-offs here. So there's plenty of use cases where an app would consist 90% of data conversions, which is not ideal. Maybe your web service is a pure database lookup thingy. I have exactly one of those in production too, and its name is literally lookup service. There, the most important business logic is mapping web requests to queries and enforcing authorization rules. And in this case, I don't care about the shape of the data. The data is just something I'm passing through. I just need to serialize it into JSON. And there's also cases where the storage technology does, in fact, affect the best way to work with the data, because maybe it's too much or too big or too fast to transform. So you have to work with what you got. So I'm emphatically not saying that you should replace your ORM with raw SQL and data classes and never touch a dictionary again. I'm saying you need to start with understanding your problem domain. And you need to understand what your software is supposed to do using what data, and then figure out what shape of data is ideal for what you're trying to achieve. Because if you want to compromise, you have to know what you're compromising on. But then when you know what you'd like to have, and you do start to compromise, you're aware of what effect or design pressure it has to pass a Pydantic or ORM object into your business code. And then you decide, is the convenience worth it, or is it not worth it? And crucially, you can look if the tools that your ORM or validation framework ships with can be used to shape the objects closer to what you'd like to have, if you can't have it outright. But for that, you need to know what you want. And you want to do all of that conscientiously, so you don't call the result fate. So, as you've hopefully noticed, at no point did I suggest that you should abandon your beloved tools. Your tools are fine. I'm here to make you aware of their siren song to paper over the tension and conflicts between different types of models with accidental complexity, which is complexity that is not inherent to the problem you're solving, and therefore making your business logic strictly worse. This is pretty much the definition of an attractive nuisance. Things look great on slides, but ruin our long-term software design. And all that to avoid thinking a little bit longer and saving a few lines of trivial code. So you don't have to precisely model your problem. Therefore, the design pressure is coming from the most dangerous place, the most human trait ever, our laziness. Fake it till you make it, as they say. And laziness can be good when it makes us automate repetitive tasks, which emphatically is not the same thing as telling a clanker to do something for you. That's not automation. Or invent higher-level abstractions. But laziness also leads us to shortcuts, and shortcuts to avoid pressing more keys on our precious mechanical keyboards, or avoiding to burn extra tokens. And this is the wrong type of laziness, because it comes with a future price tag. And we pay by having a lot more code paths to test and consider. Like, every if statement literally doubles the number of possible code paths. And if something literally doubles something, we call it exponential. And we've learned in 2020 that exponential is bad, right? Every new code path makes it harder to follow and understand what you're doing there. And yes, that's even true for your AI buddy, no matter what your wide-eyed boosters on LinkedIn tell you. And we also pay for it by having awkward data structures in places that matter. We pay for it by dealing with business code that is somehow coupled to cache implementations. I wish I would be making this up. And we pay for it by not being able to adjust our data structures to a new understanding of the problem we are solving, because any change to our accidental domain model implies changes to the web API and or database tables. And what annoys me most about this whole thing is that we try to label this behavior as a virtue by calling it simple. Because simple is great. I love simple. But there's a huge difference between easy and simple, as Rich Hickey, the inventor of Clojure, explains in his seminal talk, Simple Made Easy. Easy is not about the number of things, but about how interleaved or coupled they are. Using raw dictionaries instead of proper classes is not simple. It's familiar, it's easy. It might even be faster, so it might be an optimization, but it's not simple. Using poorly designed God classes so you don't have to write more than one and end up with a highly coupled ball of mud is not simple, it's easy. Simplicity is the result of hard thinking for delayed gratification. Ease is the result of going the path of least resistance, whatever that means for you. So whenever someone is throwing around lazy aphorisms like keep it simple, or you ain't gonna need it, or don't repeat yourself, hold on for a second and is this person actually pursuing simplicity? Can they substantiate their claims? Or are they just being lazy or shooting down things they don't fully understand? And the complexity build comes later. It's easy to parrot pearls of wisdom, and it's very difficult to have earned opinions and design truly simple systems. So, where does all of that leave us? I hope I've made it clear that it's my strong opinion that your business code is important. But if you haven't put any thought into it, it's probably buried somewhere between your form validation and database access. Go and find it, make it obvious. You don't have to rewrite it, but make it obvious. Maybe make it in a function, and so you know this is the important part. And make your data structure serve it. Keep your tools, but try to decouple your most important code from them and their idiosyncrasies. Learn them properly. Find ways to limit their design pressure on your code. And finally, for the foreseeable future, the value and importance of engineering has grown steeply. A lot of the bravado YOLO engineering you see right now will have consequences nobody will want to talk about once the chickens come home to roost. So lean into it. Actually think harder about software design, because now that every implementation is one prompt away, we've lost an important pain signal of a bad design. So don't succumb to anti-intellectualism just because they have catchy phrases. AGI is not around the corner, you may quote me, and it will definitely not save you. And that's all I have for you today. And I swear the final video of my UV trilogy will appear before the winds of winter. And with that, I'm Hynek. Thank you very much.